Also, since I do plan on going over everything, it doesn't particularly matter what order I do anything in. We're looking at the bottom here. Let's take a peek under some of these covers. So, this guy, that's interesting, they're slotted. Well, I guess, yeah, they put slotted holes for these screws, so it looks like you can loosen them up without taking them off, and then slide the cover over. Yeah. Let's get in here for a closer look. So that's what I mean about that waxy gunk. Kind of looks like after at some point they may just dip the board in wax. Because all that couldn't have migrated from the top side where the components are and coated the bottom like that. Sort of like an early crude form of conformal coating. Of course, when I solder this, it's all going to melt and make a cloud of nastiness. More of these. I got some inductors down here too. Boy, I'm going to have to be careful working around that stuff. Some coax. This one's going to be a little bit more of a challenge to get out of the set too. But this is that chroma board. This is the one where the magic happens to make color, so we want to be really careful with that. Hey, let's flip this down and try to find that color burst crystal. Alright, show you one of these guys. Just loosened up the screws holding this cover down. Interesting how they have little fingers come out to grip the tube shields. In this case, the tube shield came with the cover. Alright, so well, actually I do have some if I wanted to. This they just stuck this, but it does have a tube socket down below. They just stuck this in there. I'll pull out some so you guys can see what they look like. 356, so yeah, this is the original, I'm sure. And boy, it's not at all obvious where it goes back in. Alrighty, these are some I've come across over the years going through junk bins and such. And here's one. Looks like it was never used, but this came in a sort of top hat style package. These are the ones that are encapsulated in glass. All made by Midland, I believe. So, could I pop one of these into this set? You know, just eyeballing it and where the leads come through. Maybe. I'd have to see how it's wired down below. So, better question is, should I? These must have been more expensive than these. But is this better? Which is better? I don't know. But that looks cooler. Of course, you can't see it with the shield in place. I finished up the horizontal board and reinstalled it, then moved on to the vertical board. Now that I've decided that removing the boards isn't all that difficult, I will go ahead and do this for the remaining boards as well. Now, the vertical board, I started running into some part values that are a little more unusual, so I had to place an order. Before I did, I dug up found a copy of the RCA factory service info at the Early Television Museum website, compared it to the SAMs, and they agreed, so I went ahead and looked through all the values I didn't have on hand and ordered them up, and they just arrived. In particular, on this board, we had a .0027 rated for 1600 volts, a .12 microfarad 600, and a .056, I think it's 400. Yeah. Now, if you're thinking, hey, why don't I just run those off to the closest value, like isn't .047 close enough to .056 or .1 close enough to .12? Well, those values were readily available to them back then, and they used those in other parts of the set. So if those were close enough, they would have used them here. So they chose these values for a reason. So I went ahead and ordered up the closest I could get. Actually, I got those exact values. here is what all I got. I want to touch on a few other things. One, we have 4 multi-section electrolytic cans on this chassis. 3 of them are identical, which helps because I was able to order 10 of each value. There's a big volume discount you get with most parts vendors once you get 10 of something. In some cases it cuts the price in half, so I was happy to get that. For example, 80 microfarad at 450 volts. There's 3 or 4 of them in the set, so I just got one ahead and got 10. I did splurge a little bit on some of there are a few axial electrolytics, meaning the leads come out the end, on some of the circuit boards. I went and got Sprague Adams, even though they're ridiculously expensive, just because, well, it's a fun project. So I splurged a little bit. I think that's what's in here, and this ridiculous amount of bubble wrap. Yes, we have one tiny itty bitty capacitor. All of 5 microfarad at 50 volts. This is probably $5. So they, I guess, kind of justified the high price by lovingly wrapping it up in a big ball of bubble wrap. That's what's in there. What I really wanted to show you, though, is on these early color sets that regulated high voltage power supplies put out around 30,000 volts. In order to do that, they use a shunt regulator tube, a 6BK4, I do believe, which is a triode that can handle 30,000 plus volts on the plate. Now, across that tube, I think it's between the grid and the cathode, they have a 100 mega ohm resistor to provide biasing. Never ordered up a resistor that large in value before, but I was glad to see that there were actually a bunch to choose from. So I ordered one up. Just want to see what it looks like. It's also rated, oh, here it is. It's also rated for, I think, 5,000 volts, but there's nowhere near that much across it. Now, I don't think I have any device that could accurately measure it that high, but I read other people that have worked on these early color sets, and it seemed that replacing it was a good idea. So since I could buy one, why not? So here's a 1% ohmite, 100 mega ohm resistor. There are also a bunch of other high-valued resistors, 1.8 meg, 2.2 meg, 2.7, 3.3. So that's what a lot of the stuff in here is, higher-valued resistors, 1.5 meg, for example, and more oddball capacitor values. Tried to get axial film caps where I could, but mostly I ended up getting the Panasonic brown type, like these guys. You just manipulate the leads and flip them around, and no big deal. So now I should have all the parts I need to finish recapping it and replacing the tolerance resistors. All right, there's one other thing I wanted to mention to you guys right now, is removing corrosion. I'll pull up the whole chassis in a bit, and we'll go over the progress so far on that. But I did remove some of the shields. This one in particular, I think this is over the IF section. This was really rusty. And typically, I would soak this in Evapo-Rust or a similar rust stripper, which are a little expensive, but they do a fantastic job and fairly quickly, so that's what I typically use. However, I'm out. I've been using CLR to remove light surface corrosion on a cadmium oxide, cadmium sulfide, and very light patina of iron oxide. But this was really rusty, so I just filled up a plastic tub with CLR and threw this in just to see what would happen. It removed all of it. And fairly quickly, too, in a few hours. So you can see how pitted this surface is. This was really quite rusty. I didn't think CLR would remove rust that readily. Why do I care? Because it's cheap. And you can get it at any a grocery store, a convenience store probably, too. Here's a look back underneath the chassis. There's the board I finished. There's a board I'm working on. Next, I think I'll go after this guy. Just the soundboard. I think sync separator. Here's what I mean about the coax, where the grounded braid is twisted together and then soldered in place. So it'll be a little bit more work to get that out. And of course there are a bunch of parts that are actually on the chassis, so it will be unavoidable. I will have to get this up on there and work on it in place, but working on this stuff in the terminal strips is not quite the same as working on circuit boards where you can't easily see the part that you're working on. You got to kind of solder on one side and look on the other side. Anyways, there's that regulator tube, and that is the old 100 mega ohm resistor that I'm going to replace with that shiny new one. I also plan on doing a modification. I've been reading about Tom Carlson in particular recommended doing this. So if you look at older chassis in the CTC5, like the CTC2, or later ones like the CTC7, and I think every one after that, they have there's potentiometers to set the high voltage output. Except the 5, they took it out. They used fixed resistors. So the modification, I believe, is to replace this 1.8 with a 1.5 in series with a 500K pot. So you can go a little bit below and above 1.8. That seems to be one issue with these sets, is the high voltage tends to be a little on the low side, and well, unless you make that mod, there's no way to tweak it. There's the bottom of the flyback sticking through there. It looks fine. It looks fine. So I'm gonna keep our fingers crossed, because those replacements are not easy to come by if we should happen to need one. The can electrolytics. So here's 2 of them here, and there's 2 on the other side. I think I'll try to restuff them. I don't know. We'll see. So there's one of those dual 8040s, and then there's 2 more 8040s on the other side. Those all got to go. All the tubes. There's the board I redid. All the tubes appear to be RCA. So I don't know if they went to an authorized RCA dealership to have them service it all. No, and as I mentioned, this set hasn't seen a whole lot of servicing at all. But it does have a new picture tube. So it's a little hard to believe that a set with this much stuff going on, that it was used enough that it needed some tubes replaced and a new picture tube, but only 1 cap and 1 resistor replaced with all this stuff. Alright, that's that board then. One thing I'm a little concerned about with these boards so far is the tube sockets. They're not the greatest quality, and there's a waxy crud on these boards, and sometimes I got down into the tube socket and it was on the pins of the tube. I cleaned out the tube well enough, and I cleaned out the socket as best I could, but it has me a little concerned, so we'll want to keep an eye on that. Might want to spray some deoxit or get some solvent on there to dissolve that wax out better. I don't know. So I did clean it out. It seems to be making pretty good contact, but anyway. As for the rest of it, see, I've done some cleaning around here. Here's another tube shield where I took it off and dunked it into CLR, and it did a fantastic job. Just took the high voltage box off, so now we can really see into this flyback area. Considerably more complicated than the black and white sets you typically see me work on. So we got larger than the flybacks you typically see in a black and white set, but also more tubes. So we have the main high voltage rectifier here. There's that shunt regulator, and then there's a separate focus rectifier, and then a bunch of stuff and 3 controls. We got a switch and 2 pots up here. I believe one of them is focus. I'm not sure what the other 2 are for. As I say, there's no high voltage just on this design. Here's a progress update. These 3 boards have been rebuilt. Horizontal or vertical audio with, I think, a little bit of sync circuitry on it. Notice I have 1 cap sticking out. I did not get the right value. I missed this on my parts list when I went through it. That goes across the primary of the audio output transformer, so there can be transient spikes on it. They use a 1600 volt cap. I think it's a 0.0033 or something like that. I didn't have one on hand, This is about double the capacitance of what it should be, but it's got the right voltage rating, so I left it sticking out so to make it obvious to remind myself I should replace it. It will work just fine with this in there, but it will affect the tone of the audio a little bit, so I'm not too concerned about that. I wanted to clean up this area of the chassis before I reinstall those boards. I'm just about done, so I'll get these back in before things get too out of control. I want to get that wiring secured back down. Everything's cleaning up beautifully. Remember, this came from a machine shop near a major airport, so a lot of environmental contamination, which caused this layer of gunk and the corrosion, cadmium sulfide probably, the yellowish stuff. But it's with CLR, it's just all coming off beautifully, including the high voltage box, which I finished up. And I was able to preserve the labels, and I clear coated it with polyurethane. And we'll go back down over that. I've also started cleaning up this area. The damper tube, horizontal output tube, main high voltage rectifier, focus high voltage rectifier, and high voltage regulator. We do have a couple paper caps buried down in there, and some 2-watt high valued resistors. Looks like 2 10 meg and a couple 1 meg and maybe another 10 meg hidden back in there, and some ceramic caps. So I want to go over and check all that stuff. I'm a little surprised to see some of the wiring on this. It's uninsulated braided copper wiring. Not quite sure why they went with that, but or if that's an old repair. Likewise, this resistor that's coming off the leg of that's just going to an insulated wire going down here. I'll see if the Sam's Photo Fact has photos of this area so I can tell if that's original or if that's something that was worked on a little bit. Want to be very careful around this area. Replacement CTC5 flybacks are very few and far between. I was just reading about a guy on Video Karma who put a lot of time and effort into restoring his, and he's been using it for a while, and the flyback failed. Luckily, he was able to get a replacement scavenged, I believe, from another set. Hopefully that won't happen to me. And you might think, hey, it's crazy to do all this work when I don't know what state this is in. Well, obviously, I'm being cautiously optimistic that it's going to be okay. If it's not, well, then I'll be on the hunt for one. Simple as that. Which I guess does leave the power supply too. So we have these 4-can electrolytics up on top. 3 of them are identical, one's a little bit different. These 3 smaller ones that are identical, there's only 2 caps in each one, and there's a lot of room underneath the chassis, so I'm leaning towards just leaving these and not doing anything with them, not restuffing them, not removing them, no adapter caps, just mounting the caps down below. We'll see how that plays out when we get to it. I was reading about Doug Harland, who has an identical set, and he checked his, and 3 out of the 4 tested okay, so he just left them in the set, which is another option I could pursue as well. Now here's something you don't see every day. It's a resistor, brown, black, violet. You may have seen blue before, so if that was blue, it would be a 10 meg resistor. Violet means 7 zeros. Yeah, this is a 100 mega ohm resistor. It's used in the shunt high voltage regulator circuit. Looks rather nondescript, but it is critical to the operation of that circuit. You need accurate, correct high voltage. You need that shunt regulator circuit working, or otherwise we have all kinds of problems with the picture tube blooming and not getting good color, not getting good brightness, and that sort of thing. So you probably don't have a meter that can go up that high, or do you? So I got my Fluke 27 FM here, which I believe goes up to about 20, maybe 30 mega ohms it tops out at. So if I go on the resistance mode and try to measure this, it doesn't even detect it. We're just seeing infinity on the meter, right? But little known feature on these, if you hit range, do a few times, the watch, it says mega ohm, and that goes to NS, small n, capital S. And it's jumping around, but basically on 0 with the probes not connected. That's conductance. That is nanosiemens, the inverse of resistance. And if I short these together, so when it's open, it's 0, and when you short it, it goes infinite. It's the opposite of resistance. In this mode, this can measure up to 100,000 mega ohms. You just got to do a little math. So if I go across the leads on this, we will get a reading. 9.7 nanosiemens. You need to invert that, and if you do, you'll see it's a bit over 100 mega ohms. So I went ahead and replaced that. And yes, replacements are actually readily available from the major suppliers because they're used in test equipment, sensitive test equipment. So here's one right here, 1%, 100 meg. And these are also dissociated circuits, so 1.8 meg. Those were also a bit high, so I replaced those. For now, we will get the set working as this circuit is for now. Eventually, I think it's this one. One of these we're going to take out of circuit and replace it with a fixed 1.5 meg resistor and a 1 meg or so potentiometer to make a variable high voltage control, as all the chassis that came before and all the chassis that came after this had. The CTC5 was their attempt at making the cheapest color chassis possible. So as collectible as these sets are and cool looking, and yes, it's early color, not the greatest design. In fact, basically any other CTC is arguably better than this, but it's what we have, it's what we're going to work with. It's got a certain charm to it, so we're going to plow forward. Speaking of which, change of plans. This board was just so miserable and grungy, and I couldn't read the parts values that I did go ahead and take it out. Also, there's an old repair on here, and I think that's an old repair. I want to go over this. This is actually maybe the grungiest board in the whole set. It was a little bit trickier to get out because it had two oddball parts in it. This guy, which is a delay line, so you have two leads coming in here, one here. There's two coils of wire in there, I believe. And the way it works out with the inductance, the capacitance, and the frequency it's added, there's a certain delay between a pulse coming in and a pulse coming out that's important for how the color circuit works. And this guy down here, which is a three-legged capacitor, I think. Well, this is 2 times 10K. This might be as like a cup plate kind of thing, or a bolt plate. They have a few different names depending on who made them. Combination components. There might be resistors and capacitors inside of this thing with certain match characteristics. Not sure, but one leg of this is going to this, so I think these two are pretty important. This might have temperature compensating properties that works in conjunction with this to keep things stable, so we want to be very careful on that. So I wasn't crazy about taking this board out. We also have a whole bunch of peaking coils. Some odd component values in here too, like 910 ohm. I think we have a couple. Again, these are so grungy, even cleaning it, I can't even read the stripes on these darn things. But I think that's two 910 ohm resistors down there. So I both want to clean it and be extremely careful at the same time. But chart around here too. The 6AW8, yeah. It's a video amp tube in most sets. A dual tube. I think it's a triode and a pentode, something like that. Get a bit toasty. That could be. Yeah, it looks like there's two tube elements in there.